Hello everyone. Welcome to the world of efficiency, innovation, and business excellence. I'm Celso Bellini from Linter Systems, a company committed to changing how industry handle their production. For years, Linter has been dedicated to the research and development of technological solutions that drive the success of companies. With a highly specialized and skilled team, we work to create tools that innovate the way manufacturers plan, produce, and deliver. Today, we are present in more than 5 countries, with customers of different size, segments, processes, and ERPs, showing how flexible the solution is. Today, we are proud to introduce the result of this work, Drummer APS, a robust and innovative platform. Drummer is much more than an advanced planning and scheduling system. It is the missing piece in the operational efficiency puzzle. With Drummer, you can reach new levels of resource optimization. It has a set of integrated features that support the main links in the supply chain: customers, factory, suppliers. It's modular, so you get only what you need. Fully integrated with the main market ERPs through a fast, robust, and reliable interface, making the most out of what you have already invested in. The results are visible. There are a series of indicators, both tangible and intangible, that are improved simultaneously, generating a quick payback. Most of the times, in just a year, Drummer pays for itself. I invite you to embark on this journey with us. Over the next few minutes, I'll walk you through some of Drummer's incredible features. Let's dive into how it can boost your company in the future, providing clear vision, reliable decisions, and exceptional results. Through the system, I'll simulate some everyday issues, certain that you identify yourself with at least some of them, such as how to identify production bottlenecks, what is the best machine scheduling sequence, is it worth adding additional labor, should I prioritize delivery dates or efficiency, what is the impact of production interruptions, when can I promise an urgent order to, what to do if an urgent order pops up. I'll show you how easy it is to solve these everyday issues with Drummer. So guys, let's get started. Let's enter the system. To log in, I just input the credentials and select the environment I want to access. The system supports multi-site, multi-environments functionalities. Here we have the standard Drummer interface. Navigation is through Popeye styles menu. You expand them, revealing a vast array of features for various functions. You can organize this menu using these favorites. This section is grouped by subjects. For example, this files folder contains all the master and transactional data needed for the tool. So here you can view the entire list of items, finished goods, semi-finished goods, and raw materials. For each product, we can also view the network, its bill of materials and manufacturing routings. Inventory levels are also taken into account by Drummer, along with all aspects of demands, orders, sales forecast, requirements from other factors. In short, all this market demand is also read by Drummer. With this set of data, you can then simulate scenario creation. So how do we do that? How can we use the tool to devise the best production scenarios and then over these scenarios perform a series of simulations? We start by setting some general parameters. Okay, today is the 3rd, and I want to simulate a year ahead. We begin by reading the data. It will fetch all the relevant data for this process, and then starts to display what demand I have, what I need to deliver to the market. As mentioned, there are several sources of demand, such as sales forecasts, firm orders. I can classify these grids in Drummer. For instance, I want to view it grouped by customer, and within that, for item. If I click here, I can see all the products to customer big, and clicking here, I can see the demands from the product one for big. Notice there are 3 orders of these amounts for this date. You always have the original date and the date you can actually deliver. From here, I can easily navigate to other functions, such as material plan detail. This plan shows all the data for a specific product in terms of demands on the left side and actions on the right side. Those shop orders to be carried out by the factory to fulfill these demands. Now you can view how to run an MRP. The MRP is that phase that will generate the planning, the shop orders to meet demands. You can quickly run the MRP, generating thousands of production orders directly in Drummer. The MRP runs in memory, making it extremely fast. Notice that a shop order for a finished product has exploded the MRP structure. Here at all levels, check all intermediate stocks, adjust the dates moving backward in time from the delivery date. So remember, the tool is used to, based on market demand, create a plan and a schedule that optimize resources in a way to meet those needs with the best use of resource. That's the main purpose. But how can we determine if a schedule is really optimized and aimed to the goal? The answer lies in evaluating its impact on certain indicators. Drummer monitors these key performance indicators: on-time delivery, utilization, plant inventory levels, the number of setups scheduled for production, labor requirements. At this point, we have generated the first phase, the planning stage. Our MRP is now set. We can view how many production orders were generated by these demands. Now, these orders will be assessed from a capacity standpoint. Do we have the capacity to fulfill these production orders? The next step after the MRP is to evaluate the impact on capacity. As you progress, you can save different scenarios at various stages for comparison. In the end, our goal is to consistently and simultaneously optimize these KPIs. We know the MRP has an infinite capacity approach. What does this mean? If we evaluate the impact on delivery performance, since it's infinite, it does not adjust delivery dates. The MRP assumes 100% on-time delivery, which is, in my humble opinion, a midsummer night's dream, a pipe dream. On the other hand, if we examine the factory's utilization chart, this histogram displays all work centers over a timeline, indicating the load on each center. Notice that some are overloaded beyond 100%. The MRP often results in capacity conflicts. It insists on fixed delivery dates while requiring by far much more capacity than available. Now we can save this first scenario, say the infinite MRP, and can go further, analyze capacity in detail. For example, we can check for any production bottlenecks. For a one-year forecast, no system-generated shop orders exceed 100%. However, focused on the short term, say until November, some bottlenecks appear. This allows for quick bottleneck identification. We can also view the overall factory status. The red line indicates capacity, while the green bars represent load from shop orders. We can focus on a specific sector, say a plastic injection, and within that, a particular machine, showing how the system can zoom in and out, giving you both the big picture and the tiny detail as well. Notice that the MRPs generated conflict with tasks both in the past and exceeding the red line. So what's the next step in light of this MRP generated conflicts? It's to perform a leveling process. Leveling means moving on to the next step where we tell the system that tasks can't be set in the past nor exceed the red line, or in other words, this red line must be respected. Here, okay, it's done. If then I take the MRP profile, it's here overloaded. The reschedule, the APS profile is here leveled. From the moment I do the first leveling, I can already visualize, well, what has changed here in terms of global factory utilization. MRP is here, overloaded. The level profiles here. Notice that now I have no one exceeding 100%. The limits here. This MB, the main bottleneck, it's at the limit of use. However, no one is exceeding 100% anymore. Now, what happens to on-time delivery? If you take the performance that 100% of the MRP, now considering the factor's reality, shows that I have almost no one being fulfilled on time. If I take my demand list, let's see what happened to the orders of product A1 for the bake. Notice that it has already calculated the days I will actually be able to meet and has already projected the lateness, seeing almost a month lateness. How can you visualize this scheduling? It generated several production orders and sequenced all of them. Now I need to see the synchronism in production. I need to see the sequence I'll have on each machine. So, Drummer provides us with some features to visualize the scheduling itself. A Gantt chart is the most common way to represent the schedule. We have the list of resources vertically and a time scale horizontally. We have a series of features here. I can zoom in, for example, here on the time scale. I can zoom in here on my resource, for example, to fit more lines on the screen. I can use different color patterns. Red means delay. If I go further in the year, everything is green. I can put, for example, patterns related to each specific item or operation, customer, etc. I can filter here, for example, let's take this shop order. Here in assembly, it shows I'm gonna assemble here, I'm gonna pack here, but wait, if I have room on the resource, why wasn't it scheduled earlier if it's red? So, I have the option to make manual changes using drag and drop. Let's put this back, let's put this back. Anything you touch here in the middle will reschedule the entire queue. But pulling this back makes, will I make something unfeasible? So if I ask the system to explode here, it shows all the previous events. This assembly needs all these previous events to be met on the date. Pulling this back means I should take this whole chain and throw into the past. But I can't do things in the past anymore, right? The system is exactly for this, to avoid these scheduling conflicts. So you can visualize all these situations here. As I mentioned, you can make a series of filters, a series of searches. Okay, but I, as a good production scheduler, I glance at this chart and think, it's kind of looking at a hell map. Already everything's late. And I say, I need to improve it. I need to turn these red blocks into green blocks. How can we do that? That's where the cool interaction with the tool comes in. Drummer is a simulation tool, allowing you to interact with it really quickly. For example, is it worth it to add overtime? This is a decision we often make on a daily basis to work overtime, to introduce new shifts, and so on. Let's see how easy it is to run this type of analysis in Drummer. Let's do a quick simulation. What if I were operating with additional shifts, with added hours? Let's simulate in this. Starting today, let's say I'm scheduling 3 work shifts for the next 4 weeks. You can simulate as many shifts as you want. Here I can say it's possible to work on Sunday, Saturday, schedule it for just one machine or for the entire factory. It creates calendar exceptions here, saying in this simulation I'm using extra hours. Then I go back, Gantt chart, and ask, what's the impact of this? I run everything again with this new condition of 3 shifts. Look what happened. Visually, starting from week 42, everything's green. I can also save this scenario, this additional scenario, and guess what? You have the option to compare different scenarios. For instance, if I take the scenario where I'm working just 1 shift and scenario where I'm working 3 shifts, it shows me how much my on-time delivery improved compared to working 1 shift. And here's the trade-off, the other side of the coin. Look how operational expenses increased due to labor because you added the 2nd and 3rd shift. So, as I mentioned, folks, with Drummer, you are always seeing the impact on these indicators simultaneously. Look at that. Having added 3 shifts, did I relieve those orders from big? I can go back individually and see those 3 orders that were almost a month late and now almost on time. There's one still late, and others I can even bring forward. Back into the Gantt chart. What else you can do with Drummer? You can run simulations for those everyday challenges. Is it better go by that strict delivery date or to do sometimes use a clever trick to cut down on setups, thus improving machine efficiency? With Drummer, you can dig deeper into these kinds of analysis. You can create attributes in the work centers to emphasize what matters when sequenced. For example, if you've got plastic injection sensitive to color, you can set attributes, create preferences, matrices, and see how much you are cutting back on setups. You've got a variable setup here, and you can rate these classifications. I'll just simulate the options in the Gantt chart. Let's filter in the Gantt chart for component U1, which is an item used in many products. To provide it for all these products, the system schedules multiple orders at different times. Look how many times I've got to set up the machine for the same component. This black bar is the setup considered, 1.5 hours. Might it be worth it to batch orders for the same item in operation within a certain period? So, let's run it again, and boom, see the Gantt grouping multiple batches, doing only one setup. Then you can visually compare scenarios to see how many setups you've reduced in production, sometimes at the expense of delivery performance. Here you can see how much you have saved on setups and the potential delivery delays. It's all about weighing pros and cons, gaining on one side, maybe giving up a bit on the other. Guys, another striking feature in Drummer deals with those all too common production flow interruptions. What if a machine breaks down, or you are short on raw materials, or maybe the tools aren't available, or the workforce called in sick? How do you cope? Here's how Drummer shines. Just like I added extra hours before, I can now subtract them. Back to Gantt. Suppose one of these machines, in again, say, injection 1, with its long queue of scheduled tasks breaks down. How do I assess the damage in Drummer? Easy. I can specify, for example, that from today until the 10th, it is out of order. 2 hours available, and it's just for this machine. This can also account for scheduled maintenance and other planned downtimes. Once processed, it adjusts the calendar exceptions. Back in the Gantt, after rerunning, you will see that the machine is not available for a week. Where did that queue go? Drummer already has scheduled everything on the fly. You can then gauge the impact of this downtime. And I mean where it truly counts, like how much it hits the wallet, considering late deliveries. So you can not only analyze your KPIs, but also your delivery capabilities. Let's say this scenario where the machine was down and compare with this scenario before and compare. The system immediately tells us, hey, sales team, you might need to inform these customers that their orders are going to be a bit late. By how much? Maybe push it by a day or two because of that little hiccup in the process. This gives you a tremendous ability to react swiftly. Notice that with this tool, you can also simulate conditions where you are short on raw materials, missing a tooling, or skilled labor, etc. Finally, guys, there is also another striking feature. For instance, those commercial issues causing a lot of conflict and stress between the sales and manufacturing departments. These are those unexpected orders, a sales quote that lands out of the blue and I need to assess. Is there an available slot? When can I deliver? How do I schedule production? With Drummer, you can swiftly assess these scenarios. Let's say we have a new demand, a quote that just came in from sales. We can term it suggestively a queue jumper. For instance, the customer Big is asking for additional batch, be it one or several products. So Big wants an additional 100 units. He can ask for the earliest possible date. The earliest would be today. Let's try. I'm going to enter this as the simulation. The system has a feature where all orders, when imported from MRP, indicate their priority, meaning which orders I absolutely can reschedule due to potential penalties. And there are those orders where you can have more flexibility in adjusting delivery dates. Once I register this order, the system provides a function to assess the delivery date. In this simulation, I can also indicate an acceptable average delay for orders that are in top priority. Let's be conservative. I don't want to change any existing order. All right, I proceed. And the system iteratively tries to incorporate this new demand optimally. It's not merely trying to find slots in the schedule. After the evaluation, it informs me, well, if you don't wish to change any existing schedule, promise this order for the 18th of October without needing any adjustments. But that's too far out. All right, let's reassess. What if an average delay of up 4 days was acceptable? We simulate again. It's fast, performing all calculating in memory. It schedules thousands of orders and reschedules within seconds. It then tells me you can move it up to the 8th. In this case, the sales team needs to communicate with the affected parties on how far the queue must be adjusted. So, as you can see, it's straightforward to make these daily decisions with Drummer. It's a tool that, besides generating the production schedule, offers various simulation possibilities with great ease of interaction. Consider, for example, the linkage chain. I can analyze a particular order, like this one from Big. This order will be fulfilled by this shop order, which in turn depends on all other shop orders. From here, I can review the reasons causing any scheduling delay. It becomes straightforward to manage and monitor production using this tool. Okay, guys, this system has a series of additional features, but for now, in this video, my goal was to give you a general overview of what Drummer APS is. I hope you find this enlightening and will be releasing more videos going forward. Thanks for tuning in.